Hi AP Calc. Now we are going to do an example of an optimization problem. So optimization involves doing some derivatives and trying to kind of optimize a certain thing. In this case, we are trying to optimize the area of the largest an area of a rectangle. So we want to make the area as large as possible while keeping the perimeter of the rectangle at 200 feet. So as you can see already, it will involve some geometry and some equations. So the first step I always like to take in these kind of situations is to draw it out. Of course, this example is not too difficult, but once the problem gets harder and harder, like in the next videos, it would be useful to draw it. Alright, so we have, alright, just label this X and make this Y. So we are going to have two equations. The first equation, or the primary equation, would be what we are trying to optimize, so the area. So the area of a rectangle is X times Y. The second equation we will have, or your secondary or your accessory equation, will be the perimeter. So we are told that the perimeter is 200 feet. So we can 200 equals, the perimeter is the length around the rectangle, so it would be 2x plus 2y. So x plus 2y is our perimeter. So what can we do next? Well, we are going to work with this equation and solve for a certain variable. So if, say, let's solve for x. So I just divided everything by 2. So x equals 100 minus y. Alright, and then we have x. So what we can do is actually plug 100 minus y in for x over here. So our new equation will be a equals 100 minus y times y. Just plug that in. And if we keep simplifying that, we get 100 y minus y squared. Alright, next thing I want to do is I want to optimize this area. How do we do that? Well, we can take the derivative of it. So a prime equals 100 minus 2y. This is our derived equation. So how do I want to optimize it? Well, I want to set it equal to 0. And we just simply solve for y. Once we solve it, we know that y equals 50. And so we have the y, so we can just write y equals 50. So what would x be? Well, the easiest thing to do is to plug this value in for y in our secondary equation. So let's do that. So x will also equal 50. So it turns out that our area will be optimized when our rectangle is a square while maintaining the perimeter of 200. So of course the question goes back to find the area of the largest rectangle. So you want to find the area. So our area would simply be 50 times 50 equals 2,500 feet squared. Don't forget your units. Alright, So there's your answer, and I hope this was helpful, simple, and easy to understand. Alright, thank you.